Okay, hi everybody. Welcome to. Hey, Kristen, how you doing? Nice to see you. So nice to see everybody here at the April New York JavaSIG. Tonight we have 3 sessions since we didn't have anything for March, since we were all like traveling around the country. So we have How You talking about new build tools, which is pretty exciting. I'm going to talk about LangChain4j since some people asked me about it. Part 1. Since I only have 20 minutes, I'm doing a thunder talk. The lightning talk is 5 minutes. So this is a thunder talk since it moves more slow. So, and then we're going to have a panel of Java champions. We have pretty significant amount of Java champions in the room. We're going to talk about the conferences, as I said, March Madness. There was DevNexus, there was Java 1, there was Arc of AI, there was the NVIDIA conference. Yeah. What else? Is there anything else? Okay. So there's a ton of them, and it's always good to get the information out to the community so you can be aware of what's coming with Java and Java-related things. So that should be pretty exciting. So we'll close off with that. So the first speaker, actually, how many people are first-timers? Good, okay. Invite your friends. Invite your friends. The more friends, the more chance we can get for pizza, which isn't here this month, but hopefully next month. Okay. Any questions before I turn everything over to Hayi? Silence. Okay, Hayi, it's all yours.
Sure. Thanks, Frank. Okay. Hi, everyone. My name is Howie. As Frank said, this talk is about Java build tools. About myself, I learned Java 2004. I've been doing some open source development on JVM languages, tooling, libraries since 2012. And I've worked on Databricks, Dropbox developer tools. Right now, I'm on sabbatical working on some of my open source projects, one of which I'll talk about during this presentation. So the agenda for this talk is we'll talk about like Java build tools. So I'm sure all of you have used a build tool. No one's using JavaScript from the command line every day to compile all their code. So all of you are probably using Maven, you're using Gradle. I don't know if anyone's using anything else. Any other build tools? Bazel, Pants, Buck? No? Yeah, so all Maven or Gradle basically. And we'll talk about like, can these build tools be better? Like, are these a pinnacle of how good your build tools can be? Or is there obvious room for improvement? That's the first bullet. Like, ignoring whatever else exists, like, can these things be better than they are now? And we'll introduce Mill, which is experimental build tool. That's one of my open source projects. I kind of explore some of these ideas to see, like, can we actually implement some of the ideas to improve the existing build tools? And we'll talk about what it is, why it's interesting, and how does it work internally. So first, like, can Java build tools be better? The 3 areas I'm going to look at, which is performance, ID support, and programmability. So one thing that most people don't know is that the Java compiler is actually very, very fast. Like, it's so fast that people don't believe it. But when you put it inside a build tool, somehow the experience gets a lot slower. So for example, if I try and take Netty, you all know what Netty is. It's this asynchronous networking system framework. And I compile the whole Netty code base 10x parallel on my 10 core MacBook Pro. It takes about 50 seconds to compile the whole thing. And I can like kick this off now just so you can see. So like put this in my terminal. I have a Netty checkout here. I'm not going to wait for it. We'll just come back to it later. Hope it will be done. And the question is like, is 50 seconds or 10,000 lines of code a second compilation good or bad? And it's a hard question to answer in a vacuum. But what we can do is we can compare it against kind of a smaller benchmark where we can make a more scientific comparison. For example, if I look at the common module for Netty, this compiles in about 4.5 seconds. So again, same order of magnitude. You don't have parallelism since it's a single module. And once we have a single module, we can start doing comparisons without the build tool. For example, if I run JavaScript from the command line, it takes 1.5 seconds. Just running JavaScript using the same class path that Maven had passed in. And so this is not done yet. So while we're waiting, who here knows why JavaScript from the command line is slow? Like, this 1.5 seconds is actually the slowest you'll ever get JavaScript compile. That's might be true, but it's not the case here. And you know what? Yeah, startup. JavaScript is a Java application, runs on JVM. JVM startup slowly, they warm up, they get fast later. If you run it from command line, it starts up, exits, and never gets fast. So we are done. Okay, so it took 53 seconds in this example, compile the whole Netty mono repo. We can look at how long it takes to compile Maven. We compile Netty with Maven, so I just do a clean first. So it's a clean compile of a single module, about 4.5 seconds, more or less what we saw earlier. And if I run JavaScript from the command line, it's a bit long, but whatever. You'll see it's much faster. I'm just going to add the time to it so you can see how long it took. It's like 1.5 seconds. But yeah, so this is like the worst possible performance you get out of JavaScript. If you run JavaScript in memory, let it get hot like a JVM is meant to get hot, it should be a lot faster than 1.5 seconds. And we can see that in the next slide. So if I run this bench.java file, and bench.java, what I have here is the right folder. It's just like a single Java application with a while loop, and this while loop runs a Java compiler in memory. This just comes bundled with most JDKs, even if you don't use it. If I run this, you'll see it starts off not that much faster, but gets faster over time. It's over and over and over as your JVM warms up, your bytecode is getting compiled to fast assembly. And if I cut it, you'll see that it's now compiling Java 29,000 lines, 269 milliseconds at 110,000 lines a second. So in theory, like we should be able to compile the whole Netty code base, 500K lines. It should, in theory, take about 5 seconds on a single core. And instead, we're taking 50 seconds on 10 cores on my MacBook Pro. So there's a lot of room to spare, a lot of room to improve here. It's like not just like this build tool is better, that build tool is worse, but like the Java compiler is actually really fast. And this is actually true of many of the Java workflows, like creating assembly jars and all that. It actually can be really fast, but the build tools often don't expose this performance to you. So another thing we can look at is ID support. And like if you look at, let's say, look at this Gradle build. So this is the Gradle build for Mockito. So all of you know Mockito probably. It's a mocking framework. And you do get some ID support in terms of like you get some documentation for some of these methods. But if you jump to the methods, you often don't get much. And I'm sure if I click the right button, I can get the source files. But even without the source files and the comments, one thing you often notice in these like jump to definition is there's nowhere to go after this. So like you jump to this get JVM args, but the question is like, what was the JVM args value before they got set here? Who's using JVM args after I set it here? These are often questions you want to know if something is behaving, some plugin is not doing quite what you want, and you want to jump to definition to find out find more than the signature or the comments tell you. And in traditional build tools like Maven or Gradle, this is very difficult. And this is in stark contrast to the experience within Java application code. So if I go open any file within Mockito, I expect to be able to jump to any other identifier here and learn more about any of those things and how they're being used. So even if the documentation is insufficient, even if there are bugs, I can explore the code use my IDE, but somehow it doesn't work in your build tool. This is Gradle with Groovy. It also doesn't really work in Gradle with Kotlin as much as you'd expect it to. And Maven, you get the XML schema, but you don't really get much information beyond that. So there's room to improve here, like given how good ID support is to explore your application code, but it doesn't work for your build code. The last thing we're going to look at is like programmability. So it's surprisingly difficult to make build tools do stuff, and I don't say it's impossible, but if you add you have like a simple requirement, like let's say you want a line count of the project as a resource file. So this is a bit contrived, but it's kind of representative of the custom things that people often do in their builds. You open up Netty or Mockito code base, you often see custom parts of their build that's necessary. And it's non-trivial, it's doable. There's one Maven implementation on the right, but it's pretty tricky, more tricky than you expect such a trivial task to do. And the other ways you can do it, all of them are non-trivial. And these are things you'd expect this to be like a 30 seconds by a new grad, which should be able to bang it out correctly, but it's a lot more subtle than it seems. You can do Groovy, and like another here is Gradle, which is I guess not Groovy but Kotlin. So it's Kotlin, so it's cross-platform. You don't need to worry about bash subtleties, but lots of things you can get wrong here. So there's actually a bug in this. So and let's see if anyone can spot it. There's a bug in this trivial like project line count config task. Let's give you like the 20 seconds. Using forward slash. That's not the bug. Oh, that's not the bug. The other bugs. So the bug I'm thinking about is we are registering the wrong folder as the input file for this task. You should be registering source main Java. So if you touch the resource file, you're going to unnecessarily recompute your line count. And maybe for line count, it doesn't matter, right? Line count is fast and trivial. But for any real Groovy tasks, doing Docker containers or maybe building artifacts, it could get slow. And having it unnecessarily recompute in ways that you cannot figure out by looking at the code is problematic and tricky. Much harder than it should be given such a trivial requirement. So Java build tools maybe can be better. Next, you're going to look at one of the open source projects I'm working on, which is a Java build tool that tries to improve on these things. So this project is called Mill, and it's an experimental JVM build tool. So it works on multiple JVM languages, tries to fix the things like be faster, be easier to program, and so on. We'll see whether it succeeds later on, whether you believe it. And it's widely used in the Scala community, and there's some Java projects using it, but not so many. So it's still pretty experimental for usage in big Java projects. So a basic Mill build looks like this. So you have like a build.mil file. You have object, which is foo is a Java module. This means there's a sub-project in the foo folder. You have you define some IB dependencies for like IB repositories like Maven Central or JFrog or whatever. This one has rpath for J and a test time leaf and a test suite. So you can compile, run tests, create assemblies, run assemblies, all standard build tool stuff. Even less trivial things work. So for example, this is a Spring Boot config for a Mill Spring Boot config for a Hello World app. So if I open this up here and I go to this Spring Boot application, give me a moment for IntelliJ to import it. Okay, are you done, IntelliJ? Yeah. So here it is. I can do Mill like -- watch test the run in the background. So that's running. Now I can open up localhost 8087. That's my Spring Boot app. So I can say like hello world. And if I go back to my IDE, I can like go and make edits to the Spring Boot app. Maybe I want to change my header to like hello world. Yes, it just gets picked up automatically. Restarts. Some IDE integrations work, although not all of them, since it's still pretty experimental. For example, I can run the tests in IntelliJ, and you can see that one of the tests fails because I changed the header. It's looking for to-dos, and now it's hello world. And the other test passes, and so on. If I fix it, then both tests should pass. So it's this, rerun the test, and it works. Both tests pass now. So so far, like, next question people often ask is like, what does this support? And the answer is, it supports quite a lot of the open source tools that you may be used to. So all the different packaging frameworks, all the different web frameworks, all the different languages, and so on. It's not as battle tested as Maven or Gradle. Like, those have been around for 15, 20 years. They obviously are used much more. But to a first approximation, these things do work. And if you need to do something, you can usually get what you need done. So if Mill just does everything that existing Java build tools do, that's not interesting. So why should anyone care? And the answer is, it tries to improve upon the things that we mentioned earlier that we thought maybe are room for improvement in tools like Maven or Gradle. So in terms of performance, we did a proof of concept. We took Netty. This is quite a big project. We just ported the build to Mill. It took about a day or two. Nowadays, there's a bit of automation to help. Back then, it's literally just manually copy pasting and translating the syntax. You got all the tests passing, so actually it's quite a realistic port. It's not just a hello world compile things. And we did like benchmarks for a bunch of compilation workflows, just an example. And in most of these cases, it's much faster to compile using Mill than using Maven. We already saw this parallel clean compile example earlier, about 50 seconds. Mill, it takes about 10 seconds, and I can show it to you. So if I go to netty, so clean and compile, wildcard compile all. So you can see it's a prompt telling you, look like Gradle, telling you what it's doing. The first time I run it, it'll take a bit longer because Mill's also a JVM application. It has to warm up. First time it takes 15 seconds. If I clean and compile again, but I'm keeping the process running. I'm just cleaning all the class files and output and other resolve dependencies and stuff. Then it should be a bit faster than 15 seconds. So now it took about 9 point something. So it can be significantly faster. It's still a lot slower than it should be, right? Like it should be 5 seconds for the whole repo on a single core. That's how fast JavaSIG compiles. So we have a lot of overhead still, but not as much overhead as Maven imposes on top of JavaSIG. We did a similar example with Gradle using the Mockito repo we saw earlier. Mockito also 100K lines, 20 subprojects. All the tests passed on Mill after we ported it as a proof of concept. And the difference is not as stark as with Maven, but we are still seeing like things can be 3x, 4x faster than Gradle. So Gradle does have some optimizations, but there's still a lot of room to improve on top of that. With multi-thread, well, the first two are without and with multi-threading. This is without the global cache. So I wanted to see just if I'm actually doing stuff, how long does it take? Because Maven, Gradle, Mill all have their caches if you want to test with caches. I guess the caches are the cache workflows are somewhat in the bottom. So incrementally compiling single modules and stuff, those are with the caches enabled, and with Gradle's or Mill's incremental compiler. That's why they're both very fast. Just Gradle has a bit of overhead more. So like compilation is not everything. You see there's a bunch of other workflows. We already saw watch watch is very convenient. Mill does selective test execution. So if you make a change to a file in the code base, you can ask Mill, hey, given this git checkout, target branch, source branch, target branch, pull request branch, what test modules are affected, and what's kind of the dependency tree that says, this source root affects this, then ends up affecting the test that we need to rerun. And this is also applies to every command you run in Mill. So if you edit the file and run a command, Mill will tell you, like, it generates a JSON file telling you which tasks were rerun and how they were related to each other and the file that you edited. Assembly jars can be a lot faster. So for example, you make a big Spark submit assembly jars that takes maybe 200 megabytes, takes about 20 seconds. But in Mill, the second time you create it takes 1 second because assembly jars are just zips and you can update them incrementally. You don't need to always recreate them the whole time. And Java already has built-in functionality in the Java NIO file system to do that. So Mill just makes use of that, and it gets a lot faster for these workflows. The last thing I'm going to look at is the Chrome profile. So Mill generates this file that you can use to look at. Let me see if I open it for you. I need to go this. Open this one. So everyone has a profile visualizer on their laptop in Chrome. I don't know if anyone of you knew this before. Like, you use Chrome, you have a profile, have interactive profile explorer. So Mill generates this Chrome profile file, which is in this particular JSON format. For every command you run, just now we ran compile and all, so it's here. And just load this in. Sorry, let me try and see that again. Am I in the right folder? I think I'm in the right folder. This doesn't look like what it should look like. Let's see. Okay, that's more like what it should look like. So yeah, generates this file on every command you run, and it just tells you where your time's going. And you can click on the individual tasks to see the metadata. You can see at first my CPU was well used and got bottleneck on common, then it's other tasks kicked off, got bottleneck on transport and test compile, and so on. So again, this is not rocket science, but it's a lot more troublesome in many other build tools. Like in Gradle, you need to go pay for Gradle Enterprise and set up a server and upload build scans. Maybe need to go find the right plugin and kind of get all that set up. In Mill, you just do it for free because that's what we wanted, and I figured that's what other people may want to in working with their build tool. So my Google Slides has died. Let me open a new one. Okay, where were we? So yeah, so in terms of performance, that's where those are some nice features that Mill provides to try and improve things. Next, we can look at ID support. So the interesting thing about Mill's ID support is that it feels like exploring application code base. And I can show you what that means. So if I open up Mockito, this is a Gradle Mockito. Let me open up the Mill Mockito. This might take a moment. Okay, is it loading? Yep, it's still importing. Okay, it's imported. So if I go to the same part of the config, you'll see that on the left is Mill, on the right is Gradle. They actually look very similar. They actually all have the same JVM args and stuff. And this comes to be expected. Mill doesn't work magic. If the module requires these flags to run, well, you need to pass in these flags and tell the build tool somehow. So JVM args, the dependencies, the syntax is a bit different, but they both have like JUnit dependency. They both have error-prone test API dependency and so on. So far, nothing special. But what's different is when you jump to Gradle, you can't get stubs, which don't really tell you much and can't hit the wall. With Mill, when I define the fork arguments, I can ask IntelliJ, hey, what am I overriding? I can see where it came from. It came from here. And I can just see where it's being used. These are just methods in Mill. So fork args is used in runner. Runner gets used in run background, then run fork task. Run fork task gets used in the run task. So that's how our fork args end up being used in run. And you can explore the other way as well. For example, where does final main class come from? You see this thing here. And sure, you can look at documentation, may tell you something. But final main class comes from here, with final main class optional. Final main class optional comes from here, which is a main class. If you specify one explicitly, it uses that one. Otherwise, it uses the local main classes. Local main classes comes from this class graph worker discover main classes method call. So this is not like rocket science. You do this in application code every day. But what's interesting here is that you can't do this in Maven or Gradle. Maven or Gradle, you set these config values, but what do the values actually do? Not just the documentation, but how do they feed into each other? How do they interact with the build logic? Where do they end up being used in your assembly, jar, your packaging, your run? In Mill, you can come explore this in IDE, same way you explore in your application code base, which I think is very cool. That's IDE support. The last thing we're going to look at is programmability. So first thing to note is that Mill actually has a lot of this stuff built in, so you don't need to find plugins for a lot of it. That's kind of convenient. You just go to Mill docs and you have the stuff there for you. You want to use error-prone, you want Palantir format, it's all there. The other thing that's interesting is that Mill, that even if you want to extend it, you often can do it yourself without needing a third-party plugin. And go to the simple example. So do I have it open already? I do not have it open already. Let me open it. So over here we have this default Mill module, default Mill config. So you can see it's empty, and Mill's like Maven in that it just has defaults for all your source folders, resource folders, output folders, and so on. So if you really have nothing to configure, well, it's really empty config. Here we just say it's in a full subfolder, then it's a Java module rather than Kotlin or Scala or something else. But let's say I want to do the line count example we mentioned earlier. So how do I count the lines in the Mill build? So in Mill, you can use def line count equals task. And you can just start calling methods like foo dot source. You can ask like IntelliJ, look at all the different source methods you can call, like all source files. I can map it. So file goes to maybe file.path. I read the lines of that file path. And then I sum them up. I get the length of the lines and sum them up. Maybe I add some Java doc, so like lines of code in this module. So if I go to this folder in the command line, I can now show foo.line count to see the value. It's 17. I can inspect foo.line count. You can see that it captures a Java doc, captures the input methods for you. It's quite convenient. And that's all you need to do to define a new custom task in Mill. So the syntax might be a bit unusual. It's like a pseudo Scala syntax rather than Java, Kotlin, or Groovy that you may use in other build tools. But it's hopefully simple enough you can look at it and squint and guess what's going on, because there's not much magic going on here. I'm just defining a method called line count, which is a task, and the task calls other methods, which are tasks. And I can say, like, override the resources, which I need to do if I want to include in the resource path. So if I do override def, you see its IDE support is nice. I can call super. I can write to this task destination folder, line count.txt. I'll talk about task.dest in a moment. I'll put in the value of line count. And I'm going to append it to a reference to it, to my resource path. So what's this task.dest? Well, task.dest is a folder every task gets assigned to it that is guaranteed to be unique, which is quite convenient. So for example, if I show foo.resources now, to see what the resource path is, you can see that there's original resource folder called resources in your source folder. There's also this out/full/resources.dest. So every task gets a dest folder. And the nice thing is you can write to it and not worry about collisions. And the build tool can delete it if necessary when the task gets reevaluated. So this folder belongs to that task and no one else. So now if I look inside my resource folder, my generated resource folder, you can see there's LangChain4j has a value 17. And if I do mill foo.run, you can see it's able to read it and print it out at runtime. So in like 10-ish lines of relatively straightforward code, I'm able to configure the line count and add a custom task to my mill build with some custom logic. So I'm going to skip this part. So what's interesting here, I think, is that the logic in all these build tools is actually really the same. So look at the Maven logic. It might be in Bash. You could use Groovy as well. But the fact is, like, just wrapping up your Bash in a bunch of XML doesn't make the Bash any more declarative. It's still Bash. It's even worse. So like, there's a question like, if you need to do this custom logic, which a lot of build tools, a lot of projects end up needing to do, you try to avoid it, but sometimes you need to do it. Mill makes it just doable rather than fragile and dangerous. You get ID support in Mill, you get autocomplete, all those nice things that you're used to, rather than having this Bash in XML like experience. It's also worth comparing it with the Kotlin Gradle code. So again, this is really the same business logic. The syntax between Kotlin pseudo syntax and Scala pseudo syntax is a bit different, but it's more or less there. And the thing is with the Gradle code, the build logic, which we care about, like counting lines, isn't the error-prone part. Like, people can write a file walker line count reader with no problem. It's all the other wiring up of registering inputs and outputs. Registering depends on, do you use do last or do first and all that. That's the part that people get wrong. So with Mill, we keep the build logic. So we keep the logic of creating a resource file, we keep the logic of counting lines, but we kind of automate all the other stuff. So we capture, for example, we track the dependencies for you. So we know what methods you call, so you don't need to go register them yourself. You know what files, where you're going to write your files, and they all go to the same destination folder, so you don't need to go tell the build tool again yourself. So that's a programmability angle that I thought was quite interesting. The last section I'm going to look at is how Mill works kind of like conceptually. So the reason Mill works, I think, that makes it interesting is that it really feels like you're doing object-oriented programming. So when I say object extends Java module, it's literally a JVM object extending a superclass, and you get methods. I simplified them a bit in the top right. These methods will call each other and pass their return values. And in Mill, the objects are your sub-projects or modules. Your methods are your tasks, and your method call graph is your build graph. And you already know how all these things work, so you can already guess how it's going to work when you start configuring things. For example, when I add like a new method line kind of calls all source files, and then you override resources and call super.resources, you already know how super and override and all this stuff works. So I don't need to teach you about a special like scoping and overriding semantics for the build tool. Once we have this graph, we can do interesting things. Like you can see that, hey, line count and compiler are not related. You can run them in parallel. For this example, it's kind of silly, doesn't matter, it runs quickly. But in a bigger code base where the build gets messy, it can be very useful to have this parallelism be done for you. We can assign each task files on disk to cache things. So like line count gets cached, not useful, but the bigger task that's slow, caching is very valuable. Compile gets cached to a different place with the metadata as a JSON file and the files in the desk folder. And assembly, which also generates files, is its own desk folder, so that will never collide with compile. And lastly, we can do incremental invalidation for you because we have this graph. You touch your resource folder, which is now super.resources since you overrode it. Mill can just do a breadth first search and say, hey, resources downstream, I need to reevaluate that. Assembly is downstream, I need to recreate the assembly. Mill knows that the assembly must be in assembly.dest. So it already knows how to delete the old assembly, it must be in that folder, and recreate a new assembly, which will also be in that folder. And Mill can know that compile and line count do not need to be recreated. And Mill knows where the caches are. The caches will be at the full line count.json, to compile.json, and compile.dest. What's most interesting here is that in the build config, what you have is basically pure build logic. So there's no code here related to parallelism or caching or build graphs or anything. You don't see us registering depends-ons or input files, output files. You don't see us having threads or executors or futures. You don't see us like computing cache keys and reading, writing cache files. All that's done for you, and you just write the build logic, and Mill just takes care of all the rest. It's quite nice. 99% of the time. 1% of the time, you still need to fiddle with it, but most of the time, it's done for you. So this is kind of the second last slide. So what's interesting about Mill, how Mill works internally, is that it really uses all the concepts from object-oriented programming, not just objects and superclasses and methods and inheritance. You have inheritance hierarchies, you have extends, overrides, and super. But you already know how all these things work, so it's not an additional burden for you to remember how the Gradle like lifecycle scope registration system works, because that's unusual and new. But object-oriented overrides and super and stuff, all that's very familiar, not just to programmers, but to IDEs. So IntelliJ can jump around because IntelliJ already knows how all this stuff works. And Mill handles everything else for you, which has a few consequences, right? Like, one, the performance is much better because you don't have plugins forgetting to turn on parallelism or plugins forgetting to cache things. That happens a lot in other build tools. You don't need the clean stuff because you don't have plugins forgetting to register the dependencies or trying to do it by registering them wrong, like we saw earlier, where you have input files on the wrong folder. And it just makes life easier for the build maintainer. And maybe for the end user, it doesn't matter. But for like, this helps the Mill maintainers. That's why we can have so many built-in functionality, because it's really easy to add these new tasks and integrate things. And also for plugin authors or people who do publish Mill plugins, which I didn't talk about much, it's very easy for them to write a plugin. Like the line count code you saw earlier could just be put on Maven Central as a plugin and they're done. So that's what makes Mill kind of tick internally and conceptually, why it's interesting. So just to wrap up, this is the last slide already. I think the kind of the summary of this is, if you're someone who's already satisfied with existing Java build tools, you don't need to switch, but hopefully this talk gave you some interesting kind of food for thought. Like, why can't Maven make Maven be the default? Like, it would be nice if everything compiled 15 times faster or 10 times faster. Why doesn't Gradle just track the other tasks you call automatically, or the files you reference automatically, and save you the hassle of doing it all yourself? Like, should be doable. Not trivial, but Mill's able to do it, and Maven Gradle should be as well. If you're someone who's not satisfied with your current JVM build tools, then hopefully Mill is an interesting alternative for you to consider. You can try your next side project, even try migrating a real project to it. So the documentation is down here, and it's interesting in that, there's a bunch of examples. All the examples are downloadable, all the examples are integration tested, so you can download it and try it out with these commands and be quite sure that it works. And it's also like there's a short like migration guide if you want to try migrating existing code base, like how long do you think it will take and what's the kind of workflow for migrating. So yeah, I think that's it. The last thing is the GitHub repos here. You want to go file issues. If there are bugs, there will be bugs. It's not as battle tested as Maven or Gradle. And my email is here in case you want to contact me later. And I'm done. Thank you.
Great, thank you. Any questions?
I wasn't sure if I need a mic or okay. I'll shout and you repeat the question. So why aren't there? It doesn't look like there are scripts that could take, like, let's say Maven build and convert it to Mill. Is there any reason?
So there is an importer. It works about 80% of the way, and then the second 80% you have to do yourself. And I guess the thing is, all build tools have very different models. So the common stuff which we are able to import are things like dependencies, source roots, fork arguments, fork environment variables, all that standard stuff, Java compile options. But then you have your special Maven plugin that we haven't been able to recognize as the same as this Mill plugin. Or you have your custom Maven plugin that no one in the world knows about, except a company, then you have to port it yourself. So Mill does have an importer that is documented here for Maven, Gradle, SBT. So it does try do a best effort import, but it's not going to do it all the way, and you do need to do the last part yourself. Yeah. Other questions?
So all the IDE integration and everything, how does that work? How does it know how to actually understand the project? Is there a plugin that's needed or something?
So the Mill code uses like a pseudo Scala syntax, and IntelliJ has a Scala plugin, so that works kind of out of the box. We had to send one patch upstream to say, hey, .mil files look like Scala, and then all this works. Then the second thing, which is like the run tests and other things, IntelliJ has a protocol called BSP, Build Server Protocol. I believe they use it for Bazel, they use it for Scala, and Mill just uses the same thing. So there's a kind of JSON RPC API that Mill implements, and IntelliJ will query all the necessary metadata and ask it to run tasks or run tests and get the results back. Any other questions?
I don't have a question, but I have a comment. I've heard about Mill because I work on Scala, and I was kind of curious, especially because we have a project which is on Gradle, Scala project on Gradle. So I was curious about the performance comparisons. So I'll be curious to try it out.
Yeah.
Code will be worse than SPT. So it's
Yeah.
definitely the only way up.
Of course. No questions about that.
So why did you decide to invent the pseudo language versus, let's say, building this in Scala?
It mostly is Scala, but it avoids a lot of the kind of complex parts of Scala. Like, I'm not sure if you're familiar, but Scala has lots of very advanced features of like your super type level monad stuff. And Mill uses Scala, and Mill avoids those more dangerous or more, I guess, difficult parts. So it doesn't need like its high performance asynchronous actors. It doesn't need monads and other things. So you just stick to a very kind of a subset. But it does use a normal Scala compiler, and as I mentioned, it uses the same Scala IDE plugin, so you don't need to worry about tooling. All the normal Scala tooling works. Yeah. Okay, I guess you're done. Thank you.
Thank you. Yeah, just one. I saw you were running a mill script, so it's actually supposed to build. Can you show that?
Yeah, the mill script is ./mill. It's like Maven W or Gradle W. It downloads mill if you don't have it installed and runs it. So it's just like the Maven or Gradle bootstrap scripts. It's very, very convenient. It's like you don't need to install mill on your CI system. Just have the script in your Git repo, and you download Git, run the script, and then bootstrap everything necessary. Cool.
Thanks, Shane.
Can you back to you?
Since we're not live, I don't have to like rush. Speaking of that, so we're not going to stream live in the future or the near term. Just curious what you thought of that. And we're trying to invite people to come back face to face. I mean, that's the whole purpose of a user group, is face to face networking and learn that way. So we're going to obviously record the sessions and put them up on the YouTube website, but not going to stream unless somebody complains.
Always somebody.
Yeah, well, boy, do I know that. What? We have new technology. We have the technology now. Don't aim it at anybody, Barry.
I'm not in fault.
Okay. So I have 20 minutes for a thunder talk. Okay. So as most of you know, I've been going around to talk about AI, ML lately. So I've been focused on teaching that and using Java rather than teaching Java, with respect to that. Because I feel that we're now in the world of non-deterministic IT. It's a different world, and everybody thinks like I hear people saying like, "Oh, I got this cool AI framework. You just put this annotation in it, like magic, it works." And to me, that's a disservice, and you're going to go wrong if you believe that philosophy. So this is a brand new type of technology for all enterprises. It's non-deterministic. It's different than regular IT. If you use it like regular IT, you're going to go wrong. So that's the first thing. So in Java, since that's our favorite language, it's pretty easy to do talking to a language model, right? And this one is talking with OpenAI, the grandfather of generative AI. Although that Google has patented the transformer architecture, but that's another story. So it's one page of code, no dependencies. I could just run this in the command line, right? That's how easy it is. And you notice that on the left, there's like a little JSON language that you send with some parameters. And there's way more parameters than that, but I kept it kind of simple. But the bottom is pretty much REST, right? It's just using HTTP. And here's another example of calling Google Gemini. And notice that the little language model, the language LLM language, it's a large language model language, is different. It's different than talking to OpenAI, and it's different than talking to Anthropic, and it's different than talking to Mistral, and it's different than talking to, all the language models out there. But the bottom is the same. So there's a really really cool library, LangChain4j, which Java developers at LangChain is a Python suite that combines things together, right? So there were Java developers there said like, we need a Java API for LangChain. So they started off writing wrappers around LangChain4j, LangChain in Java, but then they started adding more and more stuff and started veering away from LangChain. So LangChain4j now is like almost like a separate thing, and it's specifically for helping Java developers talk to language models. So right now, it covers about 20 different language models. Of course, all the big ones, Google and OpenAI, Anthropic, all the big ones. And it gives you a really nice abstraction. And that's the cute logo over there, the stochastic parrot. So it simplifies language models with Java. It's a collection of common practices. It's tough to say best practices with this stuff because it's so early. They're just practices right now. Just go back. And you still need an API key, as you would imagine. And a lot of the language models let you use it for free. You just can't send thousands per second. So here's a basic architecture, or not the architecture, but the list of components. I always like to learn things from the bottom, and then using the high level, easy things, comes later. So the core components are, talking to models and prompts and memory, chat memory, all that stuff. And then there's the RAG, and I've talked about RAG here before. The document loaders and how do you chunk things, how do you break up things, and of course, embedding is one of my favorite topics, which is just fascinating. But I think for this talk, since it's only 20 or now it's 17 minutes, I'm going to focus on those three. And services, once you learn a low level, you're probably going to use services, which basically is a high level wrapper for everything. So it makes it so much easier. But really, we're in non-deterministic land now. So really understand how generative AI and how AI works in general. If you appreciate that, then you could use the Java tools. And when people say that you just use annotation, use this, and you just wave your hand, and it just works, that's wrong. That's totally wrong. We're now in probabilistic land, right? I've been doing this for a long time. My graduate project was in generative AI. We didn't call it generative AI back then. We called it computer science. Right. So there's a bunch of interfaces in the classes, very, very simple. The language model is like the interface to whatever language model you want to use. You can send prompts to it using chat messages, and chat messages can be regular messages or instructions, like want you to behave like a really polite Java instructor or something like that. And of course, chat responses, stuff you get back. And chat memory is how you maintain context. Now, that's really important. If you're going to build a chatbot, like if your manager says, we need a chatbot just like ChatGPT, notice that when you talk to it, it remembers what you said. How does it implement that? Because language models only understand this buffer called a context window. It only understands that. Only understands that. So how does it maintain context? We'll see how to do that. So this is the basic flow. You create a language model. It's an interface. So there's if you're using OpenAI, there's an OpenAI chat model. If you use Google Gemini, there's a Google Gemini chat model. You send strings to the language model. Since the language model only understands strings, it only understands strings. And it sends back a chat response. And the object that you get back, there's another type of chat message called an AI message that has the response. And it's a really cool, there's a really useful convenience method called text that you can display a text. Oops, and I forgot to talk about chat memory. So that's needed for chatbots. That's how if a language model doesn't remember what you said, since you only have a context window, well, then how does it maintain context of the conversation? There's only one way. You have to send the data over again, right? It's a stateless environment. So you need to store memory. In other words, what you said, and also what the responses were. And so over time, you're sending more and more and more and more data. Of course, the downside is that you're paying more and more and more for this, but that's another question which you should monitor. Okay. So here's an example. I'm going to use OpenAI. I'm going to send messages back and forth. I'm rushing through this because I want to show code. And you get back a response. Here's the easiest, hello world. You create this one is OpenAI. connection to OpenAI. Of course, you need to register with OpenAI to get the API key, which is no surprise to anybody. I want to use the GPT-4 model, and then I use that instance C model, and then call chat, and chat gives me back. Basically, the toString is basically the same thing as text. So that's how easy it is. So the point about this is that it's not hard. The hard part is understanding AI. That's the hard part. It's like if you were building using building a medical application, and you had a medical library to use, you better know how to know about medicine. If you're doing e-commerce and you have an e-commerce package, you better know about e-commerce. This is no different. This is not just a bunch of, we know Java, we know how to make it faster, we know about infrastructure and structure and infrastructure. That's what we know. We should take that for granted. This is new. Don't assume that you're just going to wave your hand and you're going to have AI. So it's really, really new. I think the best way is, okay, this is what I'm going to show you, and then I'll show code. So this example, which is kind of a contrived example, is just a little, I'll get something from the user. I send it off to the language model, and this one is using OpenAI. I could have easily used any one of the other ones. Now, this particular example, there's no context, and I'll show you, I'll demo this. And then this one has context. On the only lines that we have to edit are at the bottom. I just basically have to have a list and store the stuff, and they give you a nice abstraction called chat memory. So all you're doing is just adding things to chat memory. And then when you send it back to the language model, make sure you send the chat memory along with the prompt. Okay. So this is a real eye test for me. Okay, is that decent font from the computer in the back? Okay. So what this is doing is, okay, prompt. It's just getting something from the user and then running it. So this is like, okay, page of code. Let's run this guy. Where are we here? So I'm talking to OpenAI, and let's say, what are, trying to be creative here, but my brain is melted. How about yeah, actually, that would be a good one, but very similarly. Now, I'm not using the streaming API, so when you talk to language model, you can say, "Give me back like a human chatting." I'm not using that. That uses server sent events. If you know a little bit about JavaScript, that's basically streaming. I'm not doing that. That's why it took a bit of time. It's generating then dumping the whole thing over one shot. So I asked it, right? That's a lot of information. Thank you. What are Java lambdas? So now I said, what can I do with it? How does it know what it is? Could you clarify what you're referring to? Because it didn't know what it was. There was no context. So let's, so this is that readable in the back? Okay. So it's a very, very similar example. And let's see here. What am I doing here? And notice those two lines. I'm going to add this to my memory. I have the prompts that I'm sending, and also the responses. So I want the prompts and the responses together. So I'm add that to the context. Again, the context window gets bigger and bigger and bigger, but the conversation context is maintained. So let's run the sucker. Why is this shift to low? Interesting.
Does it matter which order you add the content from?
It turns out that's model specific. Usually it's not, but it depends on the model. That's another thing. So when you use prompts and models, you better be versioning stuff, because the same prompt may not work with another model. And there's these new so-called reasoning models, which I kind of laugh because machines don't reason. But these reasoning models that go step by step, that's what people call, the machine's reasoning. No, it's not reasoning. Come on, it's a machine. So there's reasoning models. The prompts that you give it may not work or work differently with a reasoning model. So if you're going to put something into production, which is scary enough to think about, but you better be versioning these things because there's a lot of different variables, right? And with the same prompt, you may get different results. How do you test that? Like, oh yeah, that's right. All right, so let's ask the same question. What are Java lambdas? And again, doing the streaming requires a little bit of architectures that are programmed, but it's not hard, right? So it gave me similar answer, and then I say, where can I use it? So now it knows the word "it" is part of the context. So it noticed that the language model has the context. So now it understands what it is and gives us a really good response. Pardon me?
What is the limit of the context?
Each model has a different context window limit. So something could be 16K, something can be 2 meg. Now there's other models that are way bigger than that. Now you might think larger is better. There are some studies saying that some models forget what's in the middle. This is early days, right? So putting things into production involves your legal department. Seriously, it does.
10 million tokens.
10 million tokens, that's pretty big. There is a paper from Stanford saying that language models forget the middle part of your context window. And why? No one seems to know. Then putting something in production, we said, I don't know. It's kind of weird to me.
How do
I write you? I'm glad you asked that question. So we're going to have speakers next month to talk about that very topic.
A check is in the mail.
It's compacting of context.
Pardon me?
LangChain support compacting of context. For example, if context is it's about maximum, we can compact it. For example, how to make it in ChatGPT.
It's what because
yeah. So there are different algorithms, different eviction algorithms for context window that LangChain supports. I'm under the impression that you can write your own, like some caching least recently used type of eviction thing.
You can try to do like summarize of your existing kind of like content.
Maybe it's already added this functionality, or it will be need to make.
Like every time when the Claude tells me like our chat is getting bigger, I just like summarize with everything what we successfully accomplished here, and I'll move on to a new one. I guess that's kind of like the way to deal with this type of stuff. You need to be kind of non-deterministic, and you need to be a little bit more kind of inventive to deal with this stuff.
Right. Then also you can make the length model more quote unquote creative. There's a parameter called temperature, which if you read the documentation, it gets it more creative. But since I did this like many, many years ago, you're basically making it more random.
Yeah.
If that's more creative,
hallucinations, yeah.
So when I originally did my project in graduate was since I'm a musician, that I looked at melodies and I said like, well, I want to determine style. So if a musician had a music and 80% of the time the next note was that way, 20% was that way, it can only go that way or that way. And I said, well, musicians don't do that. There's innovation, there's creativity, there's other ways. So I added a little random variable just to make it go down or up. So that's what temperature is. It just makes it more random. If you think it's more creative, I would suggest set the temperature to maximum and see what you get for output. It's just nonsense. It's just like random characters. So that's very creative.
The only thing that the model does, that's why I agree with Frank when he said like it's not reasoning. It's just like they're getting very good on predicting next symbol.
Yeah.
Or whatever we ask it. That's it.
So language model is, when you talk to a language model, that nowadays you're talking to a Gen AI service, right? Like a language model, it's trained by next token. That's called a completion model. But then it is another level of training that's actually called fine-tuned around how people use prompts, how people ask questions. That's another model. That's a wrapper around that. Then there's another wrapper around that, like what responses do humans prefer? So when you talk to a language model nowadays, there's actually 3 layers So it's not just like complete text completion. So that was like 3 years ago. No, it's way more than that. And even prompts, if you send prompts at OpenAI, it's verifying the prompts, making sure you don't do something dangerous, right? So this is even another model they use. So the architecture is getting more sophisticated. But for us, since a lot of us are architects, going forward, taking non-determinism and determinism and using them together, that's going to be the next step for all of us. And I'm out of time. So thank you. So now we have a panel. Okay, so we have 4 sitting and 1 standing. I'll be sitting soon.
Right.
I'll be
Yeah,
sitting.
yeah.
Java champions, and we all visited several conferences in March, and there was a lot of information. And I thought it'd be useful for all of us, and you too, Ray. There was stuff happening.
I'll grab my telephone because I don't remember.
There's a lot of new Java information that I think everybody here would benefit from. So maybe we should go chronologically with the first conference, or you want to start?
I think we should start with our names.
Oh,
I think we should start with our names and what conferences we attended. I'll start since I'm holding the mic. Gene Boyarsky, I attended DevNexus and Java 1 in March.
Donald Robb, I attended Java 1 in March.
Victor Gamov, DevNexus, I believe, and JFocus. But JFocus happened in February. I don't know if you want to judge the JFocus as well. Not that. There was also current Bangalore, but it's not really Java, but about Kafka and stuff.
Oh, Barry Bird, Java 1, and DevNexus, but not in that order. Sit down, Mo.
Yeah, okay, now I can sit. Hey, what did I go? I went to. I have a mic already. I have to.
Oh, yeah, you don't need one. All right.
So I went to DevNexus, Java 1, and Arc of AI, Venkat's conference. So where do we want to start? Do we start with DevNexus?
Chronological order.
Okay.
Well, then you're up first, Victor.
So what?
How was your February conference?
Yeah. What did you find that was a big impact to you, or what was informative at DevNexus?
So I think a lot of talks, obviously AI, and that's I don't know if it's like a self-fulfilling prophecy where the people are trying to make AI cool, but there was a lot of interesting things for Java developers, specifically LangChain, and maybe specifically what the Red Hat folks doing with the Quarkus. There's like very nice integrations with LangChain inside the Quarkus. There's lots of services already available for you, like start building apps without thinking about infrastructure, and the Spring AI on the other side. If you are in the with a group of people who prefer Spring, and there's probably another one group that do Micronaut. Let's ask, what's the Spring people? Do we have my Spring people here and Quarkus people? Not so many, but it's still cool. I highly recommend to check us out, the Quarkus, and if you would interested to learn LangChain, it's probably simplest way to do this, and they already covered a lot of things, including integration with how to do the memory, integration with tools, building the RAG type of application invoking agents, MCP, all this kind of jazz. I usually don't go to many sessions because I usually present and my talk is not ready day before. So that's why if it's not my day to present, I'm probably sitting in a hotel somewhere finishing my talk. But that was not the case this year because I did the training before. Usually DevNexus includes training day that you can go and learn some of or workshop day. I did a workshop for Java developers about Apache Flink and what you can do with stream processing there. Didn't have a chance to attend many sessions because I departed next day.
Okay. So the next conference was DevNexus. My 2 favorite memories of DevNexus were very different from each other. One of them was the opening keynote. It was Jennifer, who we have seen present here fairly recently in this room. And she talked about how she became what?
She was in Microsoft.
Oh, I'm sorry.
Yeah.
She presented in this city. Is that better?
Yeah.
Anyway, to this user group, which was the point.
Yeah.
But you're right, it was not in this room. Anyway, she gave the opening keynote and she talked about her journey to her current job. And it was cool because like she talked about music and teaching others and running a business and how it all converged. And I think that was nice because a lot of the time you hear about, I went to college and I interned here and then I became a developer. And it was really nice hearing about alternate paths to the same place. My second favorite moment was not a talk. Bruno, who also talked at this user group, although I'm afraid to suggest what room it might have been in because I don't remember that type of thing.
Bruno Souza. Bruno Souza, yeah.
Bruno Souza did a series of mentoring sessions where he organized that you could sign up to mentor and what you wanted to talk about. So I did mine for people who are early career or changing to a different career and, advice in that space. I think I had 8 or 9 people at my table, and one of them was the dad of a college student. So his kid and him were both there, and that was really cool because when the younger people or the career changers asked stuff I didn't know, I could consult with him because he's an experienced developer. It's like, well, this is my perspective. What is yours? And I really like that. I think the area was pretty popular throughout the day, and I like that the conference wasn't just talks and asking questions of the talks. I like that it had other elements of that sort. It was also the first conference where I got to publicize my book, Real World Java, and it's super important to publicize books wherever you can. Buy Don's book.
Yeah.
Thank you, Gene.
I highly recommend to anyone that's probably the only conference you need to attend. Like, or if you want to select only one, for number of speakers, or number of talks, and like Jane said, couple of talks. Networking is incredible. Oh, yeah. Do I need to repeat myself? Or okay. Yeah. So networking is incredible, and it's it's a community built conference. It's grew up from an Atlanta Java user group, and even though they invite sponsors, but it's still run by community, and it's super nice, and just cannot recommend enough.
Yeah,
Yes.
at DevNexus, the organizers are walking around. The organizers know everyone. So you don't feel as if you're at a conference where you have any concern at all about the conference. You go up and you say, "Hey, Baptiste. Hey, Vince, how you doing? Well, hey, by the way, blah blah blah." It's great that way.
All right, I'm going to try again. All right, so thank you, Gene. Yeah, it's very important to just get out there and market your book where you can. So, I went to Java 1 this year, and it's the first conference I went to and presented since Dev to Next, which was last October, September. And I'm just going to give a shout out to Dev to Next because call for proposals ends tomorrow. So Dev to Next is out in Colorado. It's run by Venkat Subramaniam. It's an excellent conference. It was, I guess, its inaugural year last year. This year it's in Colorado Springs, so I'm hoping and talk gets accepted. But at Java 1, so I gave a talk with my good friend Vlad, who's in the audience here. We gave a talk on data frames. So while AI is getting all the hubbub at all the conferences, still important to talk about stuff that actually you can put into production and use and is deterministic. So data frames are kind of cool. Like if you use Python pandas, the talk Vlad and I gave covers Python pandas, table saw.
So it was an AI talk.
Yeah. During the gold rush shovels, right? It's still data. It's still a lot of data infrastructure still important, even though maybe you're not doing something cool with like auto completion. Oh, yep, thank you.
That's all right. You can.
Yeah, thank you. You still need to know like computer science things, right? That's still important.
Yeah, and it's interesting because someone I read, I think it was Remy Forex, I'm going to quote him, said this recently. Like he said something which I found kind of interesting. He said, library should be focusing on object-oriented programming, and application should be focused on data-oriented programming. And I found that kind of interesting. And giving the talk with Vlad and talking about data frames, it's Vlad has his own library called Data Frame EC, which EC stands for Eclipse Collection. So part of the talk, which I get to give, is talking about how underneath the covers, Data Frame EC is actually using Eclipse Collection. So it's nice as an open source library developer to actually have your library used by other open source libraries and to have the opportunity to talk about that. So that's kind of cool. A highlight for me, at Java 1 this year is I got to be in the community keynote. And I think what was really cool at Java 1, it's not like previous Java 1s before the pandemic. It wasn't like super large, but I'm not sure the total number of folks, but what was cool is you had all of the folks from Oracle there. So you had like the entire DevRel team, the Java DevRel team. You had all the Oracle Java architects, and there was a great architect panel. The community keynote was quite fun. I got to talk about the OpenJDK Quality Outreach Program with David Dalabasi, who's on the Java DevRel team, and Stuart Marks, who was one of the core JDK developers. And we were talking about a bug that Eclipse Collections found as part of the OpenJDK Quality Outreach Program in the JDK. It was actually serialization bug in linked hash map.
Oh no, serialization again. Strikes back.
Serialization always strikes back. It's always
serialization.
All this AI, we got to fix serialization. So, yeah, so that was kind of cool. So I'll stop talking for a bit.
I have a question. I had to leave on Wednesday night because I was going to a robotics competition, so I got to take the red eye and missed the community keynote. Did it contain a skit?
Did it contain a skit? That's a good question. I was actually behind the community keynote for most of the time because I was on stage later. They had me queued up in a hallway. So if I missed the skit, it's possible. It's the community keynote's actually up on the.
Frank says no skit.
Okay, they did a happy birthday at the end to Duke because it's the 30th anniversary of Java in May.
That's
so
sweet.
they had Duke on stage, and when it was interesting, what they also did right after the keynote was ending, I shot upstairs to the. I did a live stream with Billy Corando, talking about got to mention my book, talked about the OpenJDK Quality Outreach Program, so that was kind of neat. Then Vlad and I gave our talk later that day, and then I shot into San Francisco and I did a podcast with Josh Long, which so it was a full day of Java streaming and talking and whatnot. It was a very long day. So, anyways, I'll pass the mic.
Can I ask a question? Yeah, thank you. So, Java 23 introduces this new gatherers, right?
Preview.
And I was wondering, I was wondering, I'm pretty sure like this stuff was already available for in form of libraries, like already for people to do kind of like windowing maybe on top of collections,
yeah,
on
it's
top
funny.
of streams.
My latest blog actually covers two of the things. So it was the first time I used gatherers. There's a window fixed, which in Eclipse Collections is called chunk. And then there's what was the other one? Let's go back and read my blog. That's why I write stuff down so I don't have to remember it all. There's another feature that actually is also in Eclipse Collections. There are two new features that aren't those. So there's a specific feature. So with gatherers, which are final in JDK 24, there's a gatherers utility, and they have window fix, Windows dynamic. No, sliding. Thank you. We don't have sliding, and there's a method called scan, and there's a fifth one. In this case, anybody know what the fifth method? So it's window fix, window sliding, scan, and no. Oh, map concurrent. Okay, Eclipse Collections probably has an equivalent of map concurrent. It's a very specialized feature, so I haven't tried it myself. So, but yeah, so it's interesting because like adding an extension point to streams is interesting. We had one extension point which were collectors, and now gatherers are a different extension point, and you can do different things with it. Eclipse Collections has a much larger API, and it's kind of like the alternative. If you want to provide an extension point where you can add whatever you want, gatherers and collectors are good for these things. Eclipse Collections says, well, these are the things that in production we saw that we needed, so we added them, right? So you don't have to add them yourself. So.
One thing that they did mention at Java 1 was a new learning website. So it's java.learn. So if you have anybody, friends or family or other students.
I think it's learn.java.
Learn.java. They own the domain, right? So it's learn.java. It's a complete, like, I wouldn't say it's an IDE, but it's a GUI type of interface to learning Java. So
is that the playground or something else?
It's the playground plot.
Yeah, there's new features that they added, right? Also, the first day, actually, to go back, the first day of DevNexus, there was the meeting of Java user group leaders and Java champions, and there was a lot of things that were discussed. Like some of the interesting ones, in my opinion, were a lot of the young developers are not learning Java; they're learning Python. So there's this initiative on how do we get the young developers to learn Java, because just Python. I mean, it's just so easy to get started with Python as opposed to Java. So there was all kinds of ideas were kind of thrown around, and every user group should now reach out to the universities and either have a meeting at the university or invite the university.
Like a game.
Yeah, okay.
Kids will want to get involved.
Exactly right.
Candyland?
Candyland
For Minecraft, yes, exactly. So that was another main topic.
And at Java 1, the 0 day at Java 1 included a session specifically for educators.
Can we call it a day 0 and not a 0 day? Because 0 days are bad.
A day before the official conference, official festivities started. And I was pleased to see Oracle investing effort in education and attracting new developers. There were
about Oracle and developers. Anyone using Visual Studio Code for writing your Java?
Oh.
Did you know that there's Java support from Oracle and Java support from Red Hat, and Oracle version is based off NetBeans, and the Red Hat version based on the. So every time when you will now there's two versions of Java support on Visual Studio Code. Now when you will be looking this today night, I hope. You can see that one now it's officially also supported by Oracle as well, and it uses like language server that comes from NetBeans versus Red Hat version that pretty much like everyone start using if you're using Visual Studio Code, that uses Eclipse language server to do with syntax highlighting and all this kind of stuff.
Also, on the day before the main day, which I refuse to call a 0 day, they talked a lot about AI and started seeing which Java champions were interested in championing AI for Java, which was really cool. Frank, do you want to add anything about that?
There is an initiative now amongst the Java champions. So we're members, and some of you are members. We're trying to promote using Java for AI. And obviously, if you're building models, your first instinct is use Python because of all the C libraries. That's sure. Use a right tool for the right job. Maybe it's not Java. Use Python. But to use models, that's where we come in, right? And especially now we're moving to the world of agents too quickly, in my opinion, but we're moving to the world of agents because we have to think about security and security at scale, not just sticking OAuth into an agent saying like, hey, that's security, right? No. So no one has done security at scale. With agents, we're talking about millions and millions of agents flying around like autonomous cars. We should think about this seriously before we put these into production. But we know about infrastructure. That's the Java developer, Java architects. That's our forte, right? It's putting things into production. So we might not fit building models, although you can use Java to build models. We're experts at putting things in production. So the timing is actually really good for us as Java developers, Java architects, because now we're using our expertise in using models. Like I showed you with LangChain4j and all these other, and then Spring AI. Although that is such a bad name, and I'm trying to say, don't call it Spring AI because it's not AI.
And don't call it that on 0 day.
Don't call it that.
But they're trying to make this cool, so that's why people.
The marketing department got it.
Exactly, yeah. Just call it AI, like everything AI, and it's gonna be work. Yeah.
Speaking of cool stuff, Java 1 was held on Oracle's campus, and you got to walk through the campus to get there. So one of the things we saw early on is they have a legal traffic sign that has Duke and Java on it. And like they actually worked through the city and made it a legal sign, which is pretty cool. I like the amount of different types of things they had at the conference. One of them was they had a lot of sessions from the Java architects. And while they did talk about the new features, they talk a lot about why they designed certain things. I live blog at most conferences I go to, so I have a lot about this on the blog. And it was nice. Like, well, we did this, but we were constrained by this, that, and the other thing. And I thought that was really cool to see. They had book signings from a number of authors, including me. Some of the books were new, some weren't, but it was nice to be, it was also meet the authors because you knew they'd be there at a certain day and time. And a few people who read my book came over to that. Not that they wanted a book, but just, it was nice to be able to say hello, which was really cool. And one of them was someone who reported errors in my book. They had the labs that they used to have in Java 1 back in the day. The rooms for the labs were too small. There was a line, like people waited half an hour and didn't get in to do the labs. So I think next time they'll use larger rooms for that so more people can do them. And of course, there were the variety of talks and panels that you would expect at a conference. It was also nice because when Java 1 was a part of Oracle Open World or Cloud World or whatever they were calling it at the time, the Java part was a small part of it. So it was harder to find the people who were, your people, because it was the whole conference. Everyone there was in the Java community. So you could talk to anybody and know that they were going to be a developer of some sort and not like, oh, well, that person's a suit. I'm bored right now. I have to find an excuse to go away. So I like the smaller environment. I think it served the conference well.
Yeah, kudos to Oracle. I mean, that was really a lot of the excitement was there. So I was glad to see that. And we were kind of worried, like, okay, it's going to be on the Oracle's campus, but it turned out excellent. And kudos to Oracle for doing that. And the null pointers got a chance to play at Java 1. We played at the party. So we have,
both, right?
Yes.
The boat.
Yeah, the boat.
Yes.
boat.
It was there in the big pond or whatever thing. Yeah.
Oh, that's it. Yeah, that was the cup, right? The boat that won the
Yeah,
cup.
yeah.
So I think I was just going to add, like, nice thing, Java 1, you can actually go to the Java channel and watch the sessions. They're adding them a bit at a time. So I think they actually have the Stream Gatherers session with Victor Klang, who's the author of it. I think they have the architect panel. So that was actually on the day you had missed. That was actually quite good because they had, they had Victor Klang, they had Brian Getz, they had John Rose, a bunch of the other architects as well. So all up there. So it was nice getting a conversation with them. Everybody, like myself, wanting to know about when is Valhalla coming. So.
One of the nice things about it being on the Oracle campus is they were able to spend money on stuff that we enjoyed and not rent. So like on the first day, dessert was a chocolate coffee cup with chocolate mousse inside, which was really good. On a couple of days, they had cookies as the afternoon snack that came from local bakeries. So like I appreciate that attention to detail more than being in some random conference center.
Desserts were amazing.
Yeah.
I have to say.
Someone needs to tell Shar we're doing this because we're sitting here advertising a conference.
I'm surprised that's not something that I know.
Well, actually, can we hear about Arc of AI?
Oh, so Arc of AI. So actually, who else went to Arc? Am I the only one? So I guess I'm the only one that went to Venkat. If everybody knows Venkat is a rock star instructor and mentor for everybody.
Anyone doesn't know that it's cool. We know
That's like saying, like, who
He
doesn't?
spoke here, and I'm pretty sure it was in this room, right?
Yes, he was.
Barry's now in charge of what rooms we meet in. Because I remember people standing in the back in a line.
He
His
attracts.
podium was on that side.
Yeah, he attracts a lot of
Oh,
people.
maybe it was in the room next door.
He had like 5 talks at his own conference. I mean, everyone was packed too, right? So it was Arc of AI. Obviously, it's an AI conference and not just Java, but a lot of sessions were about Java. Surprisingly, in a good sense, a lot of the talks were about the dangers of AI, about data bias, and since data is the food for AI, right? It's biased data. Bad data will give you bad results. So there was a lot of, there was a keynote, actually right before Venkat's keynote, there was the keynote to the keynote, which talked about some of the bad things and how also it's increasing this disparity between the wealthy and the not. I mean, that is companies getting more productive with AI, but not paying their employees that much more.
Just about everything is doing that.
Yeah, I know, sadly. But AI is accelerating that. And there were many sessions about like, here's what AI did. Is it right or is it wrong? And it's like, well, it's wrong, but it's right. It's like I help somebody, but that really hurt somebody. So there was probably 3 or 4 sessions like that, and it was pretty. I'm glad to see that, right? So not everything is rosy in AI.
So a question, I guess, for you, Frank. Used to be in June we'd have QCon New York, and I know it's in Boston. And I know Vlad's got to talk up in UConn Boston. So if you're going to Boston, I think it's a couple days up there, but are there any conferences in New York that we can go to?
Well, it's expensive, the city, right? So QCon New York.
But this is free, so keep coming here, I guess.
Yeah,
right?
this has been, which we do have a PayPal button if people want to donate money. We've been doing this for free for 30 years, so even like $5 helps, right? But being on the New York QCon committee, it's just expensive to have it. Even in Brooklyn, it's super expensive to have it. So instead of having a massive QCon New York conference, in December, there's going to be a mini QCon New York. It's not the same as the big ones, but it's going to be something smaller. And
It's going to be in Manhattan or Brooklyn? Or?
TBD,
Okay.
whether Brooklyn or Manhattan.
Ever thought of New Jersey as an alternative?
I think Chandra always wants to have something in New Jersey.
I won't speak for him, but speaking for Chandra.
So it's wherever, I'm not sure where it's going to be, but it's going to be December. And there's no call for papers. It's by invite only. So that's what's different about QCon.
And they're not inviting evangelists and developer advocates.
Evangelists. Yeah, if you want to talk about QCon, don't say you're.
I'm a developer advocate, and they still not allow me to go there. Yeah. No, it's not.
I'm on an engineering team.
Oh, okay. Developer relations engineering. I can say that.
There's certain words, and when you tell somebody, like somebody submits something, I said, well, we don't accept something from a developer, and I gotta watch how I say that. Well, I've been using this. I've been doing it for 5 years. I'm really technical. Yeah, I know, but we don't put that on our. You have to say you're on the engineering team or this. We're not a developer advocate or nothing against that. It's just that's QCon's thing, right?
Another very good conference.
It's a really good conference.
But it's not one in February or March, so we didn't get to cover it here, alas. Maybe next year.
Maybe we'll have a meeting there, wherever it is. We'll have a meeting at the same time as QCon New York. Anything else?
We should ask the audience for questions.
Yeah, any questions?
I have a question myself. Was I blindsided, or does everybody know it? At Brian Getz's session, one of his sessions, he mentioned the possibility of adding null safety in the form of question marks and exclamation points.
I want that.
Yeah, I was I didn't expect to hear that. Am I behind in not hearing that? Or just that sort of general knowledge that's filtering into the language?
Well, it's not a Jeff, right? So it's kind of a vague thought at the moment.
Okay, all right.
You mean Kotlin-esque?
Yes, exactly.
Yeah.
Groovy has it too.
Yeah.
Dart has it. I'm just
promoting AI for Java. Like, do you have any specific thoughts in mind? Like, what's your next step? Like, I've seen, like, in my company, I've seen people doing Gen AI work, but none of them they are doing in Java.
So the initiative just got started. And matter of fact, we just had a meeting yesterday to talk about like who's going to work on what, who's going to work on some materials, who's going to work on like a paper, who's going to work on this. So it's just getting started. I've been trying to do this for 5 years. I've LinkedIn articles, I have my own LangChain4j course. So I'm trying to promote it myself just to help the Java community. LinkedIn came to me and I said, like, I'll write some content on AI. So we have none on Java. Yeah. And they said, we have a lot of colleges are asking for it. So, okay,
we need a textbook. That's
It's actually free for a certain amount of time.
Yeah. So my LinkedIn course, the LinkedIn manager was very nice to me. She said that we'll make it free, because there were so many meetings. I said, like, okay, I'm going to all these meetings. We'll make it for free up until the end of June. It's like, okay, thank you very much.
Good.
Yeah, I think I sent that link around, right, to everybody? Yeah. Yeah, there's a graduate from my course.
The course is short and sweet. I did leave a couple of comments. Maybe
comments are
better, but it's already pretty good.
Sure.
So,
pardon me?
First one that you did on LinkedIn, or
yeah, the first one. The second one is on LangChain. It's going to come out soon. Yeah.
Okay. What's interesting about the AI group, which is new, is it came out of a conversation of like how can Java champions be useful? And in my mind, one of the most powerful things the Java champions did was before I joined that Java is still free article. And I think the AI work group will do way, way more than that and be a lot more impactful.
So you talked about LangChain4j, and you also mentioned emerging trends in agents. So to that end, is there anything like Lang Graph 4j?
You mean for agents specifically?
Yeah.
Well, that is a brand new field, right? And MCP is the hot thing, model context protocol, which comes from IDEs when they talk to LLMs, they don't talk directly; they talk to a proxy. I forget what that protocol is called. It's like language service protocol or something. Yeah, right. So they basically took that idea and they extended to be, well, why don't we do this for everything? And that's what model context protocol is. I'm not sure. I mean, everybody's building frameworks from MCP because everybody views that as like the next big thing. My personal thing is I'm worried about security and security at scale. It's like as if we said, like in Manhattan, every single car is going to be autonomous tomorrow. I would be a little scared. So that's what we're trying to do. And there's a lot of benefits to doing it, but it's going to do things on your behalf. You better hope it does things correct. And it doesn't cascade like in 2008 when we had derivatives. Things cascaded out of control. I get the feeling we're moving in the same direction.
Sitting in the front seat next to the driverless seat next to me, taking pictures.
What did that feel like? I saw those cars there.
It was kind of like just, I don't know. It was surreal because like you get a Waymo and it's a Jaguar. Like make it like, I don't know, a Honda or something, like quite an expensive supercar. But it was interesting. It was huh? I was yelling at him. And he wasn't responding.
Were there any moments where you felt, oh my God?
Now there were moments where I was just laughing hysterically because we were trying to make a right turn and there was traffic backed up. So the Waymo was in the left lane trying to get to the front, and then eventually it stopped and was trying to make the right. Unfortunately, it was blocking the left lane, so people were having to go around us as we were waiting to make the right. So I just thought that was kind of funny. It's like, it's, very patient.
That's the wrong standard. I have those moments in New York City cabs with a human, right? So my thing is, as long as driverless cars are better than the average cab driver, we're good.
So with driverless cars, what's the one thing that a driverless car has to? If a human being crosses in front of an autonomous car, what is it supposed to do? Stop. So if every car did that, what would pedestrians do? They'd be walking all over the street. There'd be no
That's what they do. That's what they do in New York anyway. Right? That's exactly what happens at an intersection in Midtown.
But now, if all cars are stopped, I'm just going to walk out anywhere. That's what I mean. You have to think. Like sometimes developers have to pick their head up. I guess, oh, that's what's going to happen. Like you have to kind of look up from the framework you're building. So oh, this might happen. Right.
Temperature a little bit, so it's random.
I guess another thing, to kind of disagree, I think we shouldn't look at the average, we should look at the worst. And, if Waymo, I guess you have two extreme failure modes. One, it just gets paralyzed and doesn't go anywhere, which may be not too terrible except for the person in the cab. Or it turns homicidal and just points in the direction it needs to go to and just goes. So, I would look at the outliers and not just at the averages.
So it's still state, right? It's only controlled. It's by state. Autonomous cars are only legal in certain states, right? Not cross. Is that right?
Not the whole state.
Not the whole state.
You can even limit within the city, within the different regions of city. That's how they. I think they do this they have certain places
but it doesn't go all the way down to Santa Clara.
Yeah. Well, I know at the Google campus, but
That's private property.
Yeah, it's a very big property too. Any other questions?
Oh, there we go. You're coming for a burger afterwards, right?
Yeah.
Okay, just wanted to make sure.
Yeah.
All right.
Just to give everyone a heads up, since you went to all these different conferences, can you give me an idea of the general vibe and the population of each one? Go.
Can you elaborate?
Okay, so are we talking I know the old Java ones that was part of the Oracle that was in the order of at least 10,000 plus. We're talking smaller conferences. What do we mean by smaller, mid-sized?
So Java 1 back in the day was very large, and it also included the sales teams, right? It's sales and marketing. So I'm not sure you can include what percentage was only Java, but so Java 1, I think the numbers were between 400 and 500. But so DevNexus was a little bit lighter than last year.
1,400.
It was 1,400, but was still tiny bit below.
Tiny bit lighter.
Yeah.
Yeah, they see that. Just in general observation about that, like events in the US, they are kind of sort of like in-person events. Like unless it's something big from the vendor, like AWS reInvent or Microsoft Build or I don't know, Facebook Next Summit. Very difficult for independent conferences to be, they need to be, attract some sponsors by, bringing right people there. But sponsors also don't see much of the return of investment from event.
The totally opposite in Europe. Like Europe is thriving. There's like at least in one city, in one country, in Krakow, Poland, there's 3 different Java conferences that happens with the 3-4 months. There's GeekOn, there's DevOps Poland, and there's a JDD. It's amazing. It's incredible.
All right. So what's the difference? What's happening in Europe that makes it that way there?
I don't know. Like also, like I think the demographic is. I see there's still a lot of like younger people on these conferences. So like maybe here in the US we see like Java is not cool but there's a lot of work that happens like offshore in Europe, like the Krakow, Gdańsk, the big cities where the talent are working for big companies like Dynatrace, like SignalFx, the Cisco, like all these like big companies. They have like a big engineering centers there.
So is there anything we could do here to?
Yeah, we need to make the Java cool again.
I get next.
All right.
It's not just conferences; it's meetups too. The European scene and the South American scene recovered from COVID way faster than the United States did in terms of just going to things, and that's something that's free. That's a couple hours of commitment. We talked about that a lot at DevNexus 2 years ago, and it was just like, what is helping us in New York City is more people being mandated to come into the office, because if people are in the city, they're able to go to after work stuff.
Yeah, I just have one observation because I've worked in Europe and now I work in US. It's much a good. I mean, it's easier to convince your manager that you have to go to conference in Europe. They usually take it very lightly and they sponsor you
because of the HR laws and all this kind of thing. They need to have a budget for education. Yeah, exactly.
So it was much easier for me to, okay, I want to go to this conference, and they would just like, oh, go ahead. So I think that ways it's more easier. In US, when I have to go, it's really, I have to really work hard.
Any managers in the room who needs to approve the travel for their developers, engineering managers? Okay, please send them to DevNexus. DevNexus is great. It would be good return of investment. And don't worry, they will leave after, because like if they will not, they might leave and they might stay. But if they stay and didn't go to conference, you got to work with the people that maybe not on top of the in front of the lines, in front of the curve, or how the saying goes.
It was an interesting discussion with these conference organizers. I mean, we'd sort of talk amongst ourselves and like, okay, why is this happening only in the US? And we talk to our friends that run DevOps and JFocus. We talk to Matthias who runs JFocus, and Stefan. They sell out in like hours,
including the Vox days, and including big DevOps.
So what's going on with the US? And I had some chat with Vincent and Pratik, DevNexus guys, and they said like people have budgets for education. It's just people are mentally checked out for some reason. Because it used to be that people would like, I want to work on stuff after dinner. I want to work on this stuff after dinner. And now it's like, nah, I don't want to do that anymore. So this is like a weird mentality, and it's like, why the US? This is just.
One thing I like to say is that it seems like, at least for me, my experience personally, that Java seems to be much more popular in Europe and Asia than in the US. Like recently, I was talking to a lot of friends from Silicon Valley, and of like the 30 companies I talked to, like one of them was using Java, and I was kind of shocked. And it's like, whereas you go to Europe and everyone's using Java, you go to the top 100 Java repos on GitHub, all of them have Mandarin README files. It's like all the Java is happening, but it's not happening in the US, it seems.
Yeah, I think to the Frank's point, I think this is a great opportunity for us to come back with it, because AI something meetups, they will be sold out on different places, and even in New York. So I think that's our opportunity to say like, okay, we're coming back with.
Well, all those startups, these all these conferences at AI, and it's Python heavy.
Yeah.
It's Python heavy, right? Really. And if you say Java, they look at you funny, right?
Yeah, exactly.
But any trend, the big bubble in the middle, most of those companies will disappear,
Yeah.
right? Because they lack infrastructure, they lack this. Just like the quick hitters, like I can show you, but then okay, now put into production. Oh, okay,
Yeah.
that's where we
Yeah.
come in,
Yeah.
right? That's why it's good timing for us.
Yeah, at least it's not Scala, right? So like people stop using Scala. That's a good trend. Forced. I understand this, like job security. I understand this, totally understand this. But like jokes aside, there was a kind of like, if you're doing anything with data, at least even 10 years ago, people would say, oh yeah, Python and Scala, because Scala was also somehow, because you probably need to have a PhD to use Scala, so that's why people think you're smart, so you can work with data.
But so the first part, the biggest component of any AI project is the data part, right? The data engineering is the most important part of any AI project. Mm-hmm. Java fits perfectly there. So when people say you're not going to have a job in a few years, it's like, what are you kidding? It's like you're watching too many YouTube videos, right?
We were talking about that today at Table Tennis Club. I was playing with one of the architects, and we were chatting the whole time.
You're playing tennis?
I do both. Table tennis and pickleball. We have both. Anyway, so I'm talking to one of the architects. We were talking about conferences. Then we started talking about AI and people's fears of job replacement. And what we both came to the conclusion on is that the people who don't like to learn are screwed, because it's like, well, tell me exactly what to do. We've already automated that, right? You have to want to learn things in order to have a job. But people who are curious, there's no shortage of work. And then we listed out all the other times that developers have been replaced over the years, and we're all still here.
Monetization algorithm, right? And it scares the hell out of people. It's like, they want you to your eyeballs for ads. That's why they're saying that stuff.
So totally agree what Jane said in terms of like AI. It's like it you're this or not, like Gen AI or not, it's here, it's there, and you need to learn this and use it as a tool and use this as your advantage. Knowing more, like Frank's also said, we already been here for many, many years with Java, with deployment. We know how to containerize them. We know how to bring them production. Day two responsibilities. No one is talking about the day two responsibilities. I was just like, show the project. There's MCP. That was the way how the protocol will communicate between the agents and different tools. The protocol is crap. It's a gRPC, JSON RPC. Sorry, it's a protocol from 2006. God sake. Frank spent 10 years advocating for WebSockets. I spent some less time advocating for WebSockets, like server-side push. We have a better protocols now. And hopefully now there's like Eclipse projects that's like when the adults come into room and they try to fix the situation, make this the situation with the agentic communication is more secure, more standard-driven, and more kind of like enterprise-ready. It's just like it's another tool. You need to learn another tool. Do not need to be scared about this. Someone will replace it. Someone will replace you. If you're not gonna learn the right tools, that's you will. That's on you. Like you need to stay curious. And thank you so much for coming here, because you're spending this time with us. Like it's already over 8:00. It meaning that you are right people to curious and excited about it.
Before we do the raffle and then the feed, tell us about why we should buy your book.
Well, if you like Java and you feel like you're missing things from other languages, like for many years I was missing things from Smalltalk. If you liked Scala, you like other things in Python. Like if you want to have collections that actually you can tell them to do things for you, the book will actually help you to learn those things that actually collections should be doing for you. So it's a book that I spent, 21 years writing, really, because I had to create a collections framework first, and then I from first principles starting to, okay, now I have to write a book about it 20 years later. What's interesting is writing a book about a data structures and algorithms library was a real challenge, in that I wanted to write something that I would want to read, and I would find a book about data structures and algorithms pretty dry and boring. After about a year of thinking about how to write a book, I actually came up with a strategy of taking what I saw as a problem, which is when you have a very large API, it's a bit scary to figure out where do I start to learn it. And the book actually takes an approach of taking a large API and breaking it up into smaller categories. So the things you can get out of the book, in addition to learning about a collections library, it can actually teach you about how to use strategies as API developers to make your API more learnable by other developers, right? And using basic information chunking techniques, right? Where take something big, break it down. You have a huge pie, break it into slices. This makes it consumable. The strategy that I used, I've actually blogged. I couldn't contain myself. Like, I was like, I had to, share with the world. So I started blogging about the approach I was taking in the book. There was a feature in Smalltalk which I missed, and I used it for, learned it 30 years ago. I used it without thinking about it. It's called method categories. And basically, when you create a class, before you create methods, you have method categories. And it allows you to group and organize your API. Java, JavaScript, Python, none of the languages, file-based languages, actually have this concept. And it just kind of got lost. What I talk about in the book is like, I organize things into method categories. And actually, along the way, I learned a way using IntelliJ, and other IDEs support it as well. There's a feature called custom code folding regions. You can actually organize your methods into categories or into groups. And IntelliJ will actually, I do have a blog about it. In fact, there's a picture from the blog that's actually in the book. So I wrote that, once again, I couldn't contain myself. It's like, I got a blog about this. So IntelliJ allows you to organize your methods. And if you, once again, you got a large API, you can group them together. It then displays your API in tree view. You'll have the categories first, and you can actually nest them. I haven't nested them. It also works with emojis. So if you read my blog, you'll actually see you can get emojis. Now, what I had to do by hand, it wasn't enough for me to just have the book, which I describe everything, the source code which IntelliJ can display. I wanted the Java doc to support it. I don't have a feature for that today. I've actually been talking with like the teams at Oracle about the Java doc team about getting a tagging feature into Java doc so that we can actually apply method categories to our methods, and Java doc could be built around it. So for one class, it's the main class in Eclipse Collections, I hand coded the Java doc where there's a summary of the class and every single method, which there's 150.
Yeah,
sorry. Okay. All right. You need about the book. All right. So I'm going to stop talking. It's great stuff.
Oh,
Yeah. So Frank's going to end the meeting, and then we're going to do the raffle. So it's not part of the recording.
Thank you for coming out there. Yeah. Everybody stay here, but we can end the meeting. Thank you.